You are welcome to Research Plus. This channel provides you with AI approaches to research analysis, interpretation, and reporting. If this is your first time of coming to this channel, please subscribe to the channel, and anytime I drop a high quality content video like this one, you will be the first person to be notified about it. You are welcome to class today. I want to appreciate you. In our today's lesson, we are going to take a topic, understanding linear regression. Sit back as we learn. Imagine you are at a farmer's market trying to predict the price of apples based on their weight. You notice that the bigger apple tends to cost more and the smaller apple tends to cost less. This relationship between apples' weight, which is independent variables, and the apple price, dependent variable, can be modeled using a linear regression. Regression refers to a group of statistical processes that estimate the relationship between dependent variable and one or more independent variable. Its objective is to determine the value of random variable depending on the values of the fixed variable. Its usage describes the best fit line and estimates one variable on the basis of another variable. There are 5 assumptions for linear regression to be considered, and number 1 of these assumptions is linear relationship. There should be a linear relationship between your independent variable, which is called a predictor variables, and your dependent variable, which is responses variable. In other words, the change in the independent variables should have a consistent proportional effect on the dependent variables. You can assess this with a scatter plot and visual analysis using SPSS. As time goes on, we will look into that. Number 2 of this assumption, no multiple collinearity. Your independent variable should not be highly correlated with each other. Multicollinearity can influence standard errors and lead to inaccurate coefficients and p-value. You can check for multicollinearity by calculating variance, inflection, factors, and examine the correlation metrics. Number 3 of this assumption, independent of observation. Your observation should be independent from each other. This means that the value of any one observation should not influence the value of other observation. Violation of this assumption can lead to inflected standard error and misleading result. Homoscedasticity is an assumption number 4. The variance of the error terms should be constant across all levels of the independent variables. In other words, the spread of the residual around the regression line should be consistent at all points. Violations of homoscedasticity can lead to inaccurate estimate of the variance and affect the validity of the hypothesis test. Normality of error terms is the number 5 assumptions of linear regression. The residual errors of the model should be normally distributed. This assumption is less critical than the others, but it can affect the validity of p-value and confidence intervals. You can assess normality visually with histogram and Q-plot. So as we run linear regression analysis in SPSS, we are going to see this thing very clear. I hope this tutorial has added value to your knowledge of statistics and research tools. Thank you so much. Happy to meet you in our next class.